So I have the pleasure today to show and make a review on all the glass property that all the PV producers are using worldwide. So you see a lot of glass in all the construction everywhere, and I will just show you how we produce it shortly, to remind how it's produced, and then shortly also summarize what are the key new innovation we are putting on the glass. It's not like on the back contact cells, but we put a lot of innovation more on the structure or the texture we can put and optical property. So the raw glass is produced mainly by two principal process. It can be done by float glass, by floating the melted glass on tin bats, or it can be also produced by pattern glass, by rolling between the two rolls the glass, the melted glass. So after that, of course, you have the raw, one time you have the raw material, you can cut it and transform it in the well-known process. So first of all, the float glass, you heat it at around 1,400 degrees, and you float it really, the melted glass on tin bed. So it's allowed to have very flatness. So if you look in some different PV module product, you will see that sometimes you see some waviness, some very bad reflection. When you use float glass in PV module, you have a very flat and very nice aesthetic finish. Most also very important, you have a high continuity quality of the material. So by controlling the raw sand and soda lime that we put in the material. The second process is you see we are really using roll in which in between we put the melted glass to have like a pasta, producing melted glass between two rolls to have at the end the pattern glass. The big advantage of this process is that we have the possibility to have a pattern on the glass itself. So, the next step, when you have the raw glass, you can do coating, you can do texture on the glass. You cut it, you temper it. It's also a very important process where you will see we can improve the high resistance to shock, like for safety, but also security. You use, in fact, you can implement the hail test resistance of the glass. Last but not least, before tempering also, we can also apply some digital product on the digital design on the glass before lamination. So at the end, we have review all the different property of the glass that we put on the front. Here I give you an example of the monofacial photovoltaic laminated glass, where in fact we are mainly leading and developing the glass for the front glass. But if you compare to bifacial back contact, for example, cells, you see that we can also work on the rear glass to improve the retro efficiency from the back. And you see really the very important implementation of glass in the bifacial. So the glass itself is implementing mainly three functions. You can implement mechanic, design, aesthetic, and fire resistance. I will show you also some example where we have safety property thanks to the glass, anti-glare. It's not only anti-reflective but also anti-glare. There is a lot of confusion on the market today where they are mixing anti-glare, anti-reflective. So, and last but not least also, it's very important to have very long life, durable anti-glare property. And a lot of time the anti-glare is bringing the anti-reflection and also the anti-glare property. Last but not least also the fact that we can use glass on the back and long life. We have a long durable efficiency of the back contact cells. So I will give you one example here of here it's a float glass produced in Europe. We implemented on the project in Switzerland. It is not thin glass, it was glass between 4 to 12 millimeter. But sometimes it's very important to have also, you see the very clear and very, you do not see a defect of wave or very nice aesthetic final product. Another type of product also that you see that on some project they ask the customer to have a very big texture. Last also, another implementation also, it's to put some design on the textured glass. You see digital printing made by ML System in Poland, where they were able to customize and to replace the wood there by a PV module in the spandrels area. And you see really that even in Switzerland, they are so in love with wood, they are able to use a PV module in place of natural wood. Another point on safety, the glass is also very used to increase the safety and also the hail resistance. And as you see, we were able to increase the resistance to hail by using a special process of high tempering of the glass. And we were able to produce RG5 with only 3.2 millimeter glass, which generally is asking 4 millimeter. So this storm resist, for example, can be used in different applications, but mainly here in our case for the photovoltaic. Just to show for everybody who would not be informed about the air resistance, you see that we were able to pass the maximum level of HW5. Another type of application also, it's anti-glare. As you see more and more in some application, you are obliged to place anti-glare, so non-glaring, non-reflective product, mainly in close to transportation, and more you have some airports who are obliging to place products which are not blinding the pilot or the airplane. And we have developed a product which is textured glass, allowing very good performance, and it is used mainly in the airport, where you see we are texturing both faces of the glass. You see official report where we were able to reach only 3,100 candela per meter square. You see that prismatic glass, they are not able to reach to such value, and it makes a very big difference compared to other type of solution. Here it is really texturation of the glass. There is no coating, so we are really texturating the matrix of the glass. allowing to give more than 30 years of warranty on the anti-glare property. Of course, it can be processed and marked as you see, we have a full assistance for the production and the transformation of such glass. One project that will be implemented, if you will land in Brussels airport, you will see soon such line of glass. We have heard probably about the airport of Amsterdam, which almost 230,000 modules have to be exchanged by such kind of glass due to the fact that the previous glass were blinding the pilot and the airplane. So you see really now I will make a short review of what is available on the market step by step in Europe. We have a range of normal solar glass, which is not textured, so not anti-glare, really the basic product until the special solar design product. And in the same range, the same type of glass, we are able to have to apply the solar flue coating on it. And you see that the solar flue 1.0, I would say, is the casted glass produced by melted glass pressed between two rolls. And the solar flue 2.0 is also a product based on acid etching of the glass. So at the end, well, we want really to have to propose a product where we know from where is coming the material to ensure that we have no bad element or we can recycle the product. I will summarize that in the next slide. And there is a different point that I wanted really to point out in the why the glass are really useful in the photovoltaic bifacial module. You see that, of course, it's a transparent, so everybody use it, but we need to point out that it's one of the best material to be used in PV module, and moreover in bifacial when you have two transparent layers to encapsulate the back contact cells. It's allowed to protect from all the humidity, from the oxygen, and from all the corrosive external product. It is a very long life product. The matrix itself is more than 50 years stable. It's stable to UV, but also when you work on the matrix, you are able to produce anti-glare product or anti-reflective product, allowing no degradation of the coating. A very important point also, it's recyclability. So when we produce it in Europe, we are able to certify that we have no antimony in the glass composition. It means that we can recycle it in all the different transformation of other type of glass, like glass for drink and container. Another very important point also that we need to point out, it's the fact that when we produce it locally or in China or in Europe, where you produce locally, you do not have to transport the glass from one continent to another one. That's also a very important point to take into account. And then last but not least, it's possible to have very different type of design. As I show you, we're able to mimic some different type of material to implement really PV in all the different applications, not only simply producing PV module, but also producing material having the look of stone or wood. And of course, the very important point is that back contact will allow us also to produce bifacial material, active, So it means you could have a wood having, well, panel having the look of wood, producing electricity from both sides. So, and the next step also, we give the architect all the possibility to use different type of texture. If they want, they can use also very special texture on the top of that. So, thank you for giving me the opportunity, Rado. Really, it was a pleasure. And I wish you a good visit tomorrow or during the day today of ICO also. Thank you.